Hello, welcome to Kryptonite Physics. The subject today is vector addition. To anyone that hasn't looked at this before, it can look daunting. I promise you, it is not. We are going to do top-to-tail vector addition. You don't need a calculator, all you will need is a ruler, a protractor and a sheet of paper. What is a vector? It is simply an arrow pointing in the direction of travel. Its length is proportionate to the unit being used. We are using 1 centimeter for 1 mile per hour. This arrow is 7 centimeters long, for 7 miles per hour. The boat is traveling at 7 miles per hour, in a straight line. Our first vector arrow is 7 centimeters long, pointing in the direction of travel. The tide is also running at 7 miles per hour, in this direction. We place another vector arrow on the boat. Now we add them together. Move or copy one arrow to go top to tail on the other, keeping the length and its angle, using the protractor. Draw an arrow from the bottom of the first arrow to the top of the last. This is called the resultant velocity vector. The resultant vector is showing the direction and velocity of the boat when two or more velocities are acting on the boat at the same time. Measure its length. It is 14 centimeters long, giving us 14 miles per hour in the direction of the arrow. Let's try another. The direction of the tide changes. We have 0 as our measure. The boat is not moving, because the forward motion of the boat is being cancelled by the tide. Last one. Our boat is now traveling in this direction. Place the arrows on the boat as before, then do the top to tail again. Draw the resultant arrow. Measure it. It should be 9.9 centimeters long. The boat is traveling at 9.9 miles per hour, in this direction. Just for fun, we will add another arrow, the wind blowing at 4 miles per hour in this direction. Repeat as before, adding each arrow top to tail, in no particular order. Now measure the resultant arrow. This is your velocity value, and direction. The resultant velocity is a combination of all velocities happening to one point. Imagine standing on a moving walkway that's moving at 1 mile per hour. If you stood still, you move at 1 mile per hour. If you walked forward at 1 miles per hour, you will be moving at 2 miles per hour. Walking backwards on the walkway, you are doing 0 mile per hour. You should now have a better understanding of what a vector is, how you can add one or more vectors together, what a resultant vector is, how two or more velocities acting on one point, our boat, changes the velocity of the boat, and how each velocity can act with, or against, each other.